Alright, so we have the departure here is in 990 nautical miles, which is equal to, this is in nautical miles. Geelong is something which we need to find out, multiplied by cos of, so my first leg, which is a westerly track, is along 48 degrees now. Right, so let's find Geelong now. (990) divided by cos 48. So that is 990 divided by cos of 48. Is, see how important your scientific calculator is. You have a navigational computer, but to do all these trigonometric function stuff, you have to carry this for the exam. Don't forget it. Right? So make sure you have a brand new battery and stuff. So what is cos? Yes, what is the answer? What is the Geelong?
In minutes 1479.
That's right, 1479. That's right, 0.5. So 1479.5 minutes. And also, Apeksha, learn to use the answer function which is there in the calculator. Do you know that? The answer function? ANS. So that carries the entire answer 531784. The whole decimal is already there in the answer. You don't have to memorize or round it off. And divide that by how much? 60. So we'll convert this to degrees by dividing by 60. So that is 24 degrees and
39 minutes.
39 minutes. Right. So this is a change in longitude. In what direction is the longitude changing? You're from 1 degree west, you're traveling on a track of 270, which means the longitude is changing in a westerly direction. That's right, it's changing in a westerly direction. Sorry. Perfect. Now, being on 1 degree west, you are traveling, so you got a Geelong basically, it's 24 degree 39 minutes. What is the advantage of getting this Geelong in the first leg? That's exactly going to be a Geelong on the third leg, which we know that. We are simply going to transfer this Geelong from here now. You're going to transfer this Geelong of 24 degree 39. We can keep it in minutes itself because we are going to use Geelong in minutes over here. But yes, you can transfer that here. Now what's the next step? We are trying to find out this particular latitude here. Right? Again, we apply the same departure equation. But before that, we have to find out what the value of departure is. So we're looking at leg 3 here. Right? So leg 3, departure in nautical miles is equal to distance is speed into time. Speed is again constant, the ground speed is 440 knots multiplied by 1 hour 40 minutes. How much is that? Yeah.
1.6.
That's right, 1.666 goes off like that. Right? You multiply that with 440. Yeah. 733, that's right, not even miles. Now we're going to apply the departure equation on that leg 3. So departure in nautical miles is equal to change in longitude in minutes times cos of latitude. Try writing the equation as many times as possible because you'll remember that, right? So what's the departure here? 733 nautical miles. I'm kind of skipping at 0.3 there. What is the Geelong? How will you find the Geelong? Geelong exactly same as the Geelong in the first leg because it is between the same two meridians. So that is going to be in Geelong in minutes. So it was 1479.5 minutes multiplied by cos of lat. Now yes, Apeksha, I wanted to find out this lat here by finding cos inverse. Let's see that. So let's take it here. Cos of latitude will be equal to 733 divided by 1479.5. Yes. So once we get the cos of latitude, how will we find the latitude? We have done this previously.
60 degrees 17.
So you found out cos of latitude and then you found the cos inverse of that by pressing shift and cos. How much is it? 60
degree 17 minutes.
17 minutes north. right? So it's very clear that we're looking at the answer that is more than 48 because you're going northerly, so the LP has to be more than that. So what lat is this? It is 60 degrees
60.
17 minutes north. Let me just quickly reconfirm that. So it is 733 divided by 1479.5. Shift of cos inverse of answer is 60.3 degrees, which is 60 degree 18 minutes. Yeah, it's around 17 to 18 minutes. Okay, now what's it? You're asked to find out the time taken in the leg 2. So time taken along the second leg. Time taken along the second leg. Yes, how do you find the time? Again, the basic equation, speed is equal to distance by time, which means time is equal to distance divided by speed. What is the distance? You have 440. So how will you find the distance here?
Second leg.
Yeah, second leg. Are you did you read so far? Or am I a bit rushing through?
No, I copied that out.
Yeah. Now, how will you find the time taken along second leg? To find the time, I need distance and speed. Right? Speed is already there. It's constant throughout the journey, 440 knots. How will I find this distance? This particular distance here.
It's same as
What? How to find out this distance between two latitudes?
chilat.
Chilat. So it is. We got 48 here. That is the whole point of finding this latitude because we need the chilat. So chilat is equal to 60 degrees 18 minutes. How will you find out chilat? By subtracting, right? So 60 degrees 18 minutes north. So 60 18 minutes north minus 48 degrees. Now, do you know how to enter this into your calculator? In degrees, minutes, and subtract.
Yeah.
You know that, right? Yes. So it is 12 degrees.
18 minutes.
Very good. 18 minutes. In what direction is the change in latitude happening?
Towards north.
Towards. So it's not significant here, but still, it's good to complete it. Yeah. 12 degrees, 18 minutes north. Now, how will I find the distance?
Distance.
Yeah, so no, how will I, okay, so I have to find the distance here. I have just found the chilat only. I want the distance here and then I will divide distance by ground speed to get the time. So how will I find this distance given I have the chilat?
Chilat.
Think. I have the chilat.
Divide.
I have to divide by 60.
No.
Divide by 60 is his answer. 12 degrees 18 minutes. So you divide by 60. Yeah.
1 degree is equal to 1 nautical miles.
Yes, for that you have to 1 degree is equal to 1 nautical mile.
1 minute is equal to 1 nautical
1
mile.
nautical mile. So you have to convert this to minutes first. So what is the minutes? 12 degrees 18 minutes is 720 plus 18. So 738. Correct? Right? Now, can I convert this 738 to 738 nautical miles? Can I convert 738 minutes to 730 nautical miles straight? Is it possible? By using the conversion, 1 minute is equal to 1 nautical mile. Can I do that? Why?
Not.
What's the reason for that?
We are traveling along that side.
You're traveling on a great circle, which is a meridian. Very good. That is why. So that we can do a direct conversion from minute to nautical miles. So 738 nautical miles. So once you get the distance, then you can find the time by dividing this distance with the ground speed of 440. Right? It is, remember, 738 is in nautical miles. This is in knots. Therefore, you can divide it. 738 divided by 440, which is
1 plus.
1 hour and, so tell me in hours and minutes.
1 hour 40 minutes.
That's right, 1 hour and 40 minutes. The time taken for the second leg is 1 hour 40 minutes. Is it clear? So it's a very good practice to kind of look into what I want and think reverse, and then you will understand what to find out initially. Otherwise, you will not know where to start. So I wanted the time here for which I wanted distance and ground speed. Ground speed is given in the question, so I want distance. To find the distance, since I'm traveling along a meridian, I need the chill at. And since one of the latitude is already given in the question, to find the chill at, I need the other latitude. And to find that other latitude, I need to find out what is the departure here. And to find the departure, I have the speed and time here, but I also need Chilong. And to find the Chilong here, I will find the Chilong on the first leg. And to find the Chilong on the first leg, I have the departure from here, speed and time. I also have the latitude.